There, how are you today? Let's do a interesting problem today, which was asked to me in one of the Google interviews, and I hope you'll find it exciting. The problem is as follows: we have to find the parity of a 32-bit number. So that's how the interviewer started. He started saying, "Hey, can you find the parity of a 32-bit number?" And well, I thought that's not too hard. We can always do that. Finding parity, as you know, is about seeing if there are odd or even number of bits. So I thought that's not too hard. So we just said, okay, let's do that. So find parity. This was the function signature I chose. U in 32 n. So n is the uh, incoming parameter u in 32. We have to find its parity, and we see that parity is nothing but number of is it odd or is it even number of bits set. So let's have a local variable set 0, and then we can just simply say while n we see that it is n equal to n and n minus 1. So n and n minus 1. So that's all I guess is there in is that it, but we also have to increase the set bits. So we should have actually done it probably first, or it doesn't matter. The thing is, if we go inside the while loop, that means at least there is a one bit set, right? It is a non it's a non-zero number. So now we have, and then all I did was I said, okay, if set bits mod 2 to see if it is odd or even parity. I said if it is set bits mod 2, I mean, maybe there are better ways to write this, or cleverer ways to write it, more clever ways to write it. But if you want have readability, so mod 2 equal to 0, compare it with 0, return 0, else here you return 1, right? Or it could have been written if directly return set bits mod 2. You could easily remove all this piece of code and just say return set bits mod 2, and that would basically, why would that be? Because you see, if it is divides evenly, it would return 0. If it leaves out a remainder, it would return that non-zero. So that way you will have an odd or even parity. And odd parity is if you have odd number of bits set, even parity is if you have even number of bits set. So the function signature we can say is the function is supposed to return 0 for even parity, 1 otherwise, right? Meaning for odd parity. So that's easy. But then, being a Googler, he was a Google interviewer. So obviously he wasn't happy with that, because it seemed to him that the the interviewee, which in the case which was that was me, is getting away too easily. So he kind of gave a twist in this problem. He said, what happens, because Google is all about scale. So if Google is all about scale, then he's not happy with you finding a parity of a 32-bit number. What happens if you have a million byte number, or millions of bytes, or million byte array, or something like that, jillions of bytes? So, well, that kind of put me in a quandary. I didn't know how to. I should have thought in the way like the language of C. I sort of thought in terms of C and C++, not getting confused by million bytes. But basically, all it boils down to is that you still have the same return value 0 or 1, but let's say now we try to find the, now how do we say a million bytes? As far as we are concerned, it's nothing but unsigned car message is just an array, right? Million bytes is just an array of bytes. Well, you don't represent a million bytes just like that in computer memory, right? So that's where I kind of completely went haywire, and I couldn't proceed up this point. But I don't want you guys to fall into that trap. So let's do that. So how do we do that? So one thing to understand is that how to reduce the problem. Reduce in the sense that hey, million bytes, this could be 10 bytes, 10 and 10 million bytes, doesn't matter. How do we reduce this problem? The way you reduce this problem is you have to realize that parity of a that parity of a million byte array is can be reduced to just one byte if you all you do is you say par, and then you got you just keep jar all the bytes together. And how do you go? You use a while loop to go through your your array, however you do it, but basically jar all the bytes together. This is how you do it. You could also use a for loop maybe, or you could use some other way, but par jar with message minus len. So it's interesting choice that he chose this while loop in this case. With len greater than 0, he's starting with a condition of len greater than 0. So but he will go all the way to, he will index the array for message 0 also, because he is doing pre-increment, not post-increment. So you can start with while len greater than 0, but then here if you got minus len, you will go all the way to 0th byte. So once you do that, you got the problem of billion or trillion bytes reduced to just 1 byte, right? And that was the most, I would say, that's the part you are supposed to know in advance, or at least should have in your mind, that ultimately the parity of million bytes is not, if can be reduced to finding the parity of just 1 byte if you just jar all the bytes together. Because you know why? What is the intuition behind it? Intuition is you got 1 and 0, and you see when you jar what happens. Each one cancels the one in the other side, whereas 1 and 0 you get 1. So if you have, ultimately you see all the ones that are pairs kind of will, and they are corresponding to each other in the, so basically when you do that, all the ones will cancel out, and the odd or even number of one will ultimately remain in the byte. If you take like 0, so in a byte the indexing happens from 0 to 7. So at each position, if you think about 0, now at position 0 in all the million bytes there could be ones or 0, right? As long as you have even number of zeros, or sorry, even number of ones, what would happen? You'll end up with 0, right? But if you have an odd one out, you will end up with 1. So that is the intuition behind it. Now after this, the problem just remains finding the parity of, find the parity of find the parity of par, or find car parity. In this case, find the parity of 1 byte. Just so if you think about it, ultimately it is even simpler than the one that we did for 32 bits. But how do we do that? That again we can utilize the same property, that rather than having to do by in a linear fashion, we can say unsigned width equal to char bit, which is square bit, as you know, is going to be 8. And now you're going to work each in half of that at a time. So you start with a do while loop. You say again, you do the same trick. You say you jar the half of it basically, and then if you right shift by width by 2, you wanna jar 4 bit at a time, and then you keep doing width, you keep reducing width by half every iteration of the loop, right? And you do that until width is greater than 1. So that's your comparity. All you need to do at this point is return pair mod 2. Again, the same thing, same trick, return pair mod 2. So this will give you the parity of million or billion or whatever number of bytes you got. And if you want to see it running in action, you can even write a little main program where we would be able to demonstrate that indeed is the case. So if you take, for example, let's write here, let's write a little main program to calculate the parity of, let's just say, an array of a statically initialized. Let's say you have a statically initialized array of 255, which is static uh, unsigned car, and let's say that your array is not initialized in the beginning, right? It should be initialized ideally, but we'll do the initialization in the main loop. So in the main loop, all we do is we say for int I equal to 0, I less than 256, I plus plus. What do? We do the we just go ahead and say air I. Let's say we initialize them by the index itself. So air I is equal to I. So that's our initialization of air. So array is initialized. Now imagine we call this function and say, hey, can you tell me the compute parity of this number? Okay, so how do we do that? We say printf parity of equal to, just say parity equal to, and say percentage d slash n. And you got to call this function comparity. And comparity, the signature is, you see comparity, it wants array and then the size of, see here we have a typo here, no int, it's len. So size is comparity is called with air and then the size, which is 256 in this case. And with that you should be able to see if it is high. Let's try to run this code. Hopefully it will run fine. You say line 0 out of bounds for type unsigned car 0 solution finished. Line 35 is saying I equal to 0, I plus plus air I equal to I. You say line 0 index 0 to 1 for type unsigned car. What shouldn't happen, right? Unsigned car, static unsigned car, it says index 0 out of bounds for type undefined behavior sanitizer. Why is that out of bounds, right? Oh, I see. we have to pass it the index 0 out of bounds for unsigned static unsigned car. Oh, I see. Yeah, because the thing is you got to specify the size of the array. You can't simply have array of unspecified size, right? Now you see run code. See, parity is 0. There you go. So we just found the parity of a 256 byte unsigned car, array of unsigned car. And there you go, we have your parity. You can have len as 256 or a billion bytes, or as much as Google can handle, but you're fine. So here, there we go. We got the parity. We got the parity with 32-bit number, parity of a billion bytes or whatever. I hope you guys all the best. See you next time. Bye bye.